welcome. Today, let's understand about forces. The forces involved in water movements. These forces include cohesion and adhesion force. Then number 2, capillarity. Number 3, root pressure. Those are 1, 2, 3, 4. Yeah. Those are the forces involved in what? Water movement. So we are saying we have the cohesion and adhesion force, capillarity, root pressure, and we have transpiration. Cool. Let's start with the cohesion force. How do we explain the cohesion force? This is about water molecules getting attracted. So we are saying what? Water and water molecules gets attracted, and this will be held by a bond called hydrogen bond. What about the adhesion force? The attracted water molecule will do what? Will adhere to the xylem bond. So these are what? Attracted water molecule adheres to xylem bond. And after this now falls the attracted cohesion and adhesion force, there will be a continuous stream flow of water. This there will be what? Continuous stream flow of water. And it will be up the xylem vessel of the leaf to the xylem vessels of, from the xylem vessels of the stem to the xylem vessels of the leaves, from the xylem vessels of the roots to that of the stem to the roots. That is it. Then number 2, we'll have this force, which is our, this was force number 1, number 2. Then we have number 3, we'll speak about the root pressure. Root pressure. Or the root pressure is a push force. We explain being a push force. So what happens after the water molecules are attracted? What follows is that water molecules, it will flow from the soil to the cortical cell, then from the cortical cells to the epidermis. The same way to the mineral salts. The mineral salts will move still by either active transport or adhesion, depending on the concentration gradient. As it flows, it will flow to which point? It will flow to the endodermis. Once in the endodermis, they will be pushed by this root pressure to the xylem vessels of the roots, where it will exert high osmotic pressure and draw water to the xylem vessel by the process of osmosis. So we are saying this one will be at endodermis. Next place at endodermis. The root pressure will be happening at endodermis. And we are saying what happens? Mineral salts will be what? Will be pushed by a force, and this will be to a xylem vessel roots. We are saying there will be a push force that will push these mineral salts to the xylem vessels of the roots. And we are saying it can either happen by 2 ways, active transport or dilution. So from the endodermis, there should be energy, which will push this water, not mineral salts, to the endodermis. Not to the endodermis, but to the xylem vessels of the root. Once in the xylem vessels of the root, it will exert osmotic pressure. So the mineral salts exert osmotic pressure in xylem vessel roots, xylem vessel of roots, and draw water by osmosis. And it will draw water by osmosis. It will draw water by osmosis. Now from that point, we will have another force, which now will be the capillarity. We are speaking about another force, which is what? Capillarity force. This force is created in the xylem vessel because of the narrowness. You still understand me say xylem vessel wall is narrow. Make the word narrow. It has a narrow lumen, so the word has a what? Narrow lumen. And because of this narrow lumen, what will happen? This now enhances capillarity. It enhances capillarity. We have said the water molecules are attracted to the xylem vessels. Once in this world, because of the narrowness, the water will do what? Will start to rise up. It will rise up from xylem vessel roots to that extent to xylem vessel leaf. That is it. That is the capillarity. So we are saying just capillarity is because of the narrowness of the xylem vessel. And this xylem vessel being narrow, it will enhance capillarity. And the water will start to rise through this narrow lumen. So let's go to the last one, which is about the transpiration pool. From this capillarity force, once in the xylem vessels of the leaves, it will go to which point? To the sponge mesophyll. Sponge mesophyll. Then once in the sponge mesophyll, the water will be transpired. So from the transpiration pool, it comes from transpiration. Water is lost in form of what? Water vapor. We lose water in form of water vapor. And once we lose the water in form of the water vapor, the sponge mesophyll, that's the airspace, becomes highly concentrated. So we are saying what? Sponge. We are saying transpiration will take place. We lose water in form of the water vapor. That's how we explain transpiration. And the sponge mesophyll layer becomes more concentrated. It becomes more concentrated than xylem vessel B. And because of this one, the xylem vessels of the leaf, and because of this one, there will be an exerting of the osmotic pressure. Osmotic pressure in the sponge will increase. So osmotic pressure increases, guess what? Osmotic pressure in sponge mesophyll increases. And because of this one, there will be a force being created. Which force? Pull. The pull force is created. Once this pull force is created, water now will now be taken up from this lower section, that is the xylem vessels of the roots, from the xylem vessels of the stem to the xylem vessels of the roots, then to the upper section, that is xylem vessels of the leaves to replace the water loss. And these will maintain a continuous stream flow of water. That is the end of the forces involved in water movement. So next we will discuss about the absorption of water and mineral salts from the soil. Thank you very much. Subscribe and like.